Have you ever wondered what's really happening inside your phone when Netflix recommends the perfect movie, or how Google search seems to read your mind? The magic behind it all is something called AI algorithms. But what are they, really? Let's break it down. Nice and simple. Imagine you're baking a cake. You have a recipe, right? It's a set of step-by-step instructions. Mix flour and sugar, add eggs, bake at 350 degrees. An AI algorithm is just like that recipe, but for a computer. It has a series of instructions that tells a machine how to solve a problem or make a decision. Instead of flour and sugar, its ingredients are data. At its core, an AI algorithm tries to mimic human thinking. It analyzes vast amounts of data, spots patterns that we might miss, and learns from the results to get smarter over time. Every single algorithm has an input and an output. It takes in data, processes it through its recipe, and produces a result. This could be anything from translating a sentence to identifying a cat in a photo. The ultimate goal is automation and intelligence, making our technology smarter and more helpful with less and less human effort. Think about your daily life. When you use Google Maps to find the fastest route, that's an AI algorithm at work. When Siri or Google Assistant answers your question, that's another one. They're already woven into the fabric of our digital world. So now that we know what they are, let's talk about the different flavors of AI algorithms. Not all are created equal. They're designed for different tasks. The simplest kind are rule-based algorithms. These follow strict if-then logic. For example, if the temperature is below freezing, then turn on the heater. It's very straightforward. No learning involved. Then you have search algorithms. These are fantastic at finding the best solution out of countless possibilities. Think of a GPS planning your route. It's not just finding *A** path. It's searching for the *optimal* path, considering traffic, distance, and road closures. Now for the really exciting stuff. Machine learning algorithms. Unlike rule-based systems, these algorithms learn from data. They aren't explicitly programmed for every single scenario. Instead, they identify patterns in past data to make predictions about the future. Within machine learning, there are a few key types. First is supervised learning. Imagine showing a child flashcards of cats and dogs. You point to a picture and say cat, then another and say dog. You're providing labeled examples. Supervised learning works the same way. We feed it labeled data like emails marked as spam or not spam, and it learns to categorize new, unseen data on its own. Next is unsupervised learning. What if you just gave a child a big pile of animal photos without any labels? They might start sorting them into groups based on shared features, furry ones here, feathery ones there. That's unsupervised learning. It finds hidden patterns and structures in unlabeled data. Businesses use this to discover different customer segments they never knew existed. Then there's reinforcement learning. This is how we teach machines through trial and error, just like training a pet. When the machine performs a desired action, it gets a reward. When it makes a mistake, it gets a penalty. Over millions of trials, it learns the best strategy to maximize its rewards. This is the technology that powers AI in games, robotics, and even self-driving cars, teaching them to navigate complex environments. Going even deeper, we have deep learning algorithms. These are inspired by the structure of the human brain, using what's called a neural network. These networks have layers of neurons that process information, allowing them to learn incredibly complex patterns, like recognizing faces or understanding speech. And finally, we have natural language processing, or NLP algorithms. These are specifically designed to help computers understand, interpret, and generate human language. Every time you talk to a chatbot, use a translation app, or see autocomplete suggestions as you type, you're interacting with an NLP algorithm. Okay, let's get a bit more specific. You'll often hear names of famous algorithms thrown around. Let's quickly demystify some of the most popular ones so you know what they do. First up, decision trees. Imagine a flowchart. The algorithm asks a series of questions to split the data into branches, leading to a final decision. It's super intuitive and easy to visualize, making it great for clear decision-making. Then there's linear and logistic regression. Linear regression is used to predict a continuous value, like trying to predict a house's price based on its size and location. Logistic regression is for yes or no questions. Will a customer click this ad? Does this patient have a certain condition? It gives a probability between 0 and 1. K-nearest neighbors, or KNN, is a simple but powerful idea. To classify a new data point, it just looks at its K closest neighbors in the existing data and goes with the majority. If the 5 nearest data points are all cats, it's probably a cat. Support vector machines, or SVMs, are excellent at classification. They work by finding the best possible line or boundary to separate data into distinct groups, creating the widest possible margin between them. You might also hear about naive Bayes. It's a simple algorithm based on probability that's surprisingly effective. especially for text classification tasks like filtering spam. We mentioned neural networks earlier. They are the powerhouse behind deep learning, composed of interconnected nodes that mimic the brain's neurons to process complex information. For unsupervised tasks, k-means clustering is a go-to. It groups unlabeled data into a specified number of k-clusters, with each data point belonging to the cluster with the nearest mean. Finally, there are ensemble methods like random forests and gradient boosting. Instead of relying on a single model, they combine the predictions of multiple weaker models to create one highly accurate and robust prediction. A random forest builds many decision trees and averages their outputs, while gradient boosting builds models sequentially, with each one correcting the errors of the previous one. So, how do these algorithms actually get put to work in the real world? It's a fascinating process. It all starts with data. Lots and lots of data. The quality and quantity of your data are everything. The saying, garbage in, garbage out, is the golden rule here. The dataset needs to be large, diverse, and clean for the algorithm to learn effectively. Once you have the data, you split it. A large chunk becomes the training data. The algorithm is fed this data, and it starts learning the underlying patterns. During this training phase, it continuously adjusts its internal parameters to improve its accuracy. Think of it like a student studying for a test. After training, it's time for the exam. We use a separate set of data, the testing and validation data, which the algorithm has never seen before. This step is crucial to ensure the model can generalize its knowledge to new real-world situations, and wasn't just memorizing the training examples. We measure its performance using metrics like accuracy, which tells us how many predictions it got right, as well as precision and recall, which give a more nuanced view of its performance, especially when dealing with imbalanced data. Of course, all this learning requires a ton of computational muscle. Processing huge datasets and running complex calculations for deep learning models often requires specialized hardware like GPUs, or graphics processing units, which are much faster at these tasks than traditional CPUs. But building an AI model isn't just a technical challenge. There's a massive ethical component. We have to be incredibly careful to ensure our algorithms are fair and unbiased. If a training dataset contains historical biases, for example, biased hiring data from the past, the AI will learn and amplify those biases, leading to discriminatory outcomes. Ensuring fairness, transparency, and accountability in AI is one of the biggest and most important challenges in the field today. So, from a simple recipe to a complex neural network, AI algorithms are the engines driving the modern world. They're what turn massive streams of data into intelligent actions, predictions, and insights. It's a field that's constantly evolving, and by understanding these basic building blocks, you're now better equipped to understand the technology that is shaping our future. Thanks so much for watching. If you found this guide helpful and want to learn more about AI and technology in a simple, clear way, make sure to hit that like button and subscribe to the channel. Let me know in the comments what you'd like to see demystified next. See you in the next video.